Hello to the Art of Worldbuilding podcast, episode number 11, part 2. Today's topic concludes our talk about how to create a planet and focuses on climates. This includes understanding the role of the equator and oceans, climate zones, prevailing winds, rain shadows, and of course the climates themselves. This material and more is discussed in Chapter 2 of Creating Places, Volume 2 in the Art of Worldbuilding book series. Do you want practical advice on how to build better worlds faster and have more fun doing it? The Art of Worldbuilding book series, website, blog, and podcast will make your worlds beat the competition. This is your host, Randy Ellefson, and I have 30 years of worldbuilding advice, tips, and tricks to share. Follow along now at artofworldbuilding.com. Climate is one of those subjects that most of us probably don't find very interesting, but I think that's partly because most of us don't really understand it. I mean, we have a basic understanding just from living on the planet, but we don't really understand the details of it that actually do make it interesting, and we certainly don't understand how those apply to a world that we are inventing. So by the time we're done with this podcast episode, I think you will find it more interesting than you do right now. Or at least, that's my hope. When it comes to climate, there are things that affect the entire planet's climate, and then there are things that are happening on a more regional level. So first we're going to talk about that bigger picture. And the two primary things we want to focus on are the equator's role and then the role of the ocean. Let's first talk about the equator. We all know what one is, but it's basically an imaginary line. It doesn't actually exist. It's just a line that's equidistant between the North Pole and the South Pole. One of the things about the equator is that days and nights are exactly the same length there all year round. This changes the farther north or south you go towards a pole to the point where it can be night for 6 months and then day for 6 months at one of the poles. It's also perpetually hot there, except at higher altitudes where it's a little bit cooler. As a general rule, things tend to remain the same at the equator, and the equator is sometimes the exception to some of the other climate things that we're going to talk about today. Since things stay the same, one of the things we don't really have at the equator is the normal 4 seasons that most of us experience. They just don't exist. Well, technically they do exist, but they're so subtle that they may as well not. If you are building a fantasy world where the characters in that region never leave that area, then they may not even understand the idea of the seasons, the same way that they would have never seen snow. Now, they do have something instead of the 4 pronounced seasons, and that is basically a wet season and a dry season. Some places are actually wet all year, but many of them are just wet for something like 200 days a year on Earth. Of course, this means that they are predominantly wet. If you don't like rain, you probably don't want to live near the equator. And now if you're building a world where there are inhabitants who never leave the equator, then they are probably very used to the rain. They probably take it for granted, and their culture is likely to have something to do with this abundant rainfall. Life in this area is often based upon the rain. If you are setting a story at the equator, you should take into account that it's probably going to be raining on the characters most of the time. If this is something you don't want in your story, then you might want to move it farther from the equator. For those of us who write science fiction, you may have wondered why spacecraft on Earth are usually launched from Florida, and the reason is that this is closest to the equator in the United States. The reason this matters is that the escape velocity needed to escape our atmosphere is less at the equator because the planet is spinning faster there. So if we're building a science fiction planet, we might want to consider this. We may have decided that the propulsion systems on that planet are so powerful that they don't need to worry about this anymore, but it could be more realistic to decide that they do still need to worry about this and plan our strategy and our books more with that in mind. One of the things you can do with this is have a kingdom that is near the equator, and therefore it is in control of the territory on that continent. And there's another kingdom farther north, for example, and that kingdom, the northern one, wants to send spaceship into space, but it can't. It has a harder time doing so because it's farther from the equator, and this might cause it to try engaging in a war to gain territory that is closer to the equator. So this is one way in which our research into world building and how the planet works and just physics can help us think of a story scenario. In the previous episode, we talked about the Earth spinning counterclockwise, which is why the sun is rising in the east and setting in the west. This is important to remember as we continue through this episode because some of the other issues I'm going to talk about have something to do with which direction the winds are going, and that is based on the direction that the planet is spinning in part. But the reason I mention it right now is that in order for spacecraft to take advantage of this, they have to launch in an easterly direction. So you could again have another scenario where two kingdoms do have territory near the equator, but one of them must launch its spacecraft over the other one to get into space, and as a result, it's very likely to be shot down. Of course, this is assuming that they are enemies. Personally, I find this kind of detail more interesting, and this is part of what I alluded to at the beginning, where understanding climate and other things about our planet can make just the subject of climate more interesting. And in this case, it can also impact our story and add a nice bit of realism to what we are doing. Another issue we should talk about when it comes to the equator is that when we are inventing a continent for our world, we should always make an early decision how far from the equator this continent is. This may not seem like it matters at first, but the distance from the equator is going to determine the direction of the prevailing winds, and those are what carry moisture from one place to another, and that moisture can be blocked by mountains, and that is going to cause something that we're going to talk about in a few minutes called rain shadows, and this also causes the location of deserts and forests. So all of this is related to how far from the equator is this landmass. If you're not sure why any of that matters, by the time we conclude this podcast episode, you will. If you're looking for more world-building resources, artofworldbuilding.com has most of what you need. This includes more podcasts like this one, and free transcripts if you'd prefer to read an episode. You can also find more information on all 3 volumes of the Art of Worldbuilding series, which is available in ebook, print, and audiobook formats. Much of the content of those books is available on the website for free. You can also join the mailing list at artofworldbuilding.com/newsletter. This gets you free, reusable templates from each published volume in the series. You don't even need to buy the books to get these. I also send out contest information, free tips, and other stuff to help with your efforts. Please note that I do not share your email address with anyone because that's against my privacy policy, and you can unsubscribe at any time. Sign up today to get your free content and take your world building to the next level. Now we're going to talk about the ocean and its effect on the climate, which is actually quite significant. If you have a world that has almost no oceans, then the climates are going to be much more stable everywhere. But as I mentioned in the previous episode, we are focused on creating an Earth-like planet, not one that has so little water. With that in mind, we're going to take a look now at how the oceans affect climate. The first thing to understand is that the ocean absorbs a lot of heat from the sun. It then distributes that heat around the world as the oceans move. If your planet is not rotating but is tidally locked to the sun, this is not going to happen, but that does not fit our description of an Earth-like world. But I did want to mention that. Something to be aware of is that the water tends to circulate in certain directions, and what I'm talking about is, we have one ocean that is really the entire planet, but here on Earth we call parts of that ocean the Pacific Ocean or the Atlantic Ocean, even though they're really one giant body of water. But that aside, the Atlantic Ocean, the water in that area, it spins in a certain direction, and which direction that is has to do with which direction the Earth is spinning itself. And as it turns out, it's also different in the southern hemisphere versus the northern hemisphere. This might sound a little complicated, but it's actually easier than it seems. In fact, all of the oceans in the southern hemisphere are rotating counterclockwise, whereas the oceans in the northern hemisphere are rotating clockwise. Since many of my listeners are either going to be in the United States or in other English-speaking countries like Europe, I'm going to focus on the northern Atlantic Ocean as an example. The northern Atlantic Ocean, between the United States and the northern coast of Africa and Europe, is spinning clockwise. And what this means is that warm water from the equator is going up the eastern side of the United States, and conversely, cold water from near Europe in the northern part of Europe is going down towards the equator along the coast of Africa, and then it goes back across it goes west across the equator. So the ocean is spinning in a giant circle. They say a picture is worth 1,000 words, and it turns out I've got one on the artofworldbuilding.com website. It's under the Creating Places book. There is a page for all the images that are in the book, and it is figure 14 from chapter 2. It shows all of the ocean currents on Earth, with blue arrows showing where the cold water is going, red arrows showing where the warm water is going, and black arrows showing water that's probably basically in between the two of them. Even without the picture, it's relatively easy to picture this. If you just imagine the Atlantic Ocean in the north, and you're looking at the map, The water on the left side of the ocean is going up, and then it goes across the top to the right, then it goes down the right side of the ocean, and then back left across the bottom. So what does this mean for climate? Well, on the eastern coast of the United States, there is warm water that is going up that coast, and as a result, this is impacting the climate by bringing warmer and moist air there. The opposite is true on the other side of the United States, where the Pacific Ocean is bringing cold water down from Alaska along the western coast of California and Oregon and Washington State. And as a result, the water is much colder there. So as someone who grew up on the eastern United States, I am used to going into the ocean in the summer and having the water being relatively warm. And I have gone to vacation on the western side of the United States and gotten in the water there and been shocked at how cold it is. And this is what's going on. Now, I did mention the idea that you could decide to have your planet rotating in the opposite direction. The Earth is going counterclockwise. If you decide to have your planet going clockwise, then that means that all the ocean direction of the currents that I just talked about will be reversed. Now, I did mention that in the southern hemisphere, the water is swirling in the other direction, but as it turns out, the effect is the same, and here's what I mean. Regardless of whether you are in the northern or southern hemisphere, the water on the western coast tends to be colder than the water on the eastern coast. It's true regardless of which hemisphere that you are in. The reason this is true is that in the southern hemisphere, the cold water from the pole is being pulled counterclockwise up the right side of the ocean, which means, once again, it's on the western edge of a continent. Similarly, since the water is going counterclockwise, the water from the equator is going down the left side of the ocean, which is the the eastern and right side of a continent if we're looking at the map. So the rule does hold true. Regardless of hemisphere, on Earth or any planet where the world is spinning counterclockwise, the water on the west coast is colder and the water on the east coast is warmer. As we continue our talk about climate, you'll see how this affects everything. For those of you who support crowdfunding, I am on the Patreon site and would appreciate any support you can lend. It can be just $1 a month. Higher levels of support get you increasingly cool things, such as PDF transcripts, MP3s of my music, which you hear in these episodes, free ebooks and short stories, bookmarks, and even signed copies of books and CDs of my music. Many of these are unavailable to the public. Your support can help me cover the expenses of producing the show. Even better, you can help me promote it and make it more successful. Without you, there's no point in doing this. Are you benefiting from this free podcast? If so, just go to artofworldbuilding.com and click the big icon for Patreon. And thank you for your support. The next issue we need to talk about that affects climate on a global scale are the climate zones, and there are 4 of these: the tropics, subtropics, temperate zones, and polar zones. We're going to start at the equator and work our way outwards, and this means that we're going to start our discussion with the tropics. These run from 0 degrees, which is the equator, to roughly 23.5 degrees latitude. What really defines this is not the latitude, but the spot at which the sun appears to be directly overhead at its highest point in the sky. Naturally, most of us have no idea where that really is, so it's just safe to say that, at least on Earth, it's roughly 23.5 degrees. If your planet is roughly the same size, then it's going to be roughly the same spot. This isn't something we really need to worry about too much, other than just having a general sense of where that is. If yours is 23 degrees or 24 degrees on your planet that you're inventing, that's perfectly fine. No one's going to call you out on that and say, well, that's not true, because, of course, we're inventing a planet that doesn't exist. One of the most important aspects of the tropics is that they move the heat away from the equator towards the poles. This is true both in the ocean and in the atmosphere. That said, the tropics are not a climate, they are a climate zone. And what I mean is that if we have colder ocean temperatures or even warmer ocean temperatures and mountain ranges, these can further modify the climate on the continents. For example, if the water is very cold, then the atmosphere is going to be a little bit colder there. And if the mountains are very high right there, then the air is thinner up there, and this is also going to have an effect on the climate. If this is a little bit unclear on exactly how that works, it will become more clear in a few minutes when we talk about the actual climates themselves. Right now we're talking about climate zones. And what do I really mean about a climate zone? We're talking about a general area, in this case of the tropics, from 0 to 23.5 degrees. And this goes all the way around the Earth, both north and south of the equator. This is a zone. The actual climates that are in that zone are affected by being in that zone, but they may differ from the average. And we're going to talk about that more in a few minutes. Now, you may have heard the terms Tropic of Cancer and Tropic of Capricorn. These are just the names of the northern and southern tropics, respectively. On an invented world, we're going to want different names for these, and that raises the question of how do you choose a name? Let's say we're talking about the northern tropics, and you have a kingdom on one of the continents that is synonymous with the area between the equator and roughly 23.5 degrees. In other words, it's mostly filling up that area, the tropics. You could name the tropics after that and have that be on your map so that you just call it the Tropic of Antaria if the Kingdom of Antaria is filling up that area of the northern tropics. Now, it's true that in another part of the world, they may call it something else, but this is going to depend on how much travel is really happening on your world. And let's face it, most of us are never going to mention this, so what you call it isn't really that important. However, it can be relatively easy to make up a name like this, and if you have a sailing story, for example, where a character is traveling into the tropics, it might add a little bit of realism to throw out the name in your narration or in dialogue. Since the tropics end at roughly 23.5 degrees, they give way to the subtropics, which run from there until about 40 degrees. As you might expect, this area is a little bit cooler. On Earth, as it turns out, most of the world's deserts are in this region. Further from there is the temperate zone, which runs from roughly 40 degrees latitude to 66 degrees latitude. And this is arguably the most important one, at least here on Earth, because the majority of the world's population lives in that zone. In this zone, coastal areas experience a milder winter and summer than areas that are farther inland, which experience a greater range in temperatures. In other words, it's going to be even hotter and colder within the interior of a continent than it is on the coast. And the reason for that is the moisture in the air, and that is caused by the currents in the ocean. It's also worth noting that if you have a very high altitude area in this zone, it might essentially act like it's farther north in the polar zone. What I mean is that it's essentially going to be a lot colder as if it's farther north because of how high it is. And the last area we need to talk about is the polar zone, which is basically from the pole all the way down to 66 degrees latitude. There isn't really much to say about this that isn't perfectly obvious to all of us. Now, I recognize that some of that information is kind of dry, but you're in luck because the next two subjects we're going to talk about are prevailing winds and rain shadows, and both of those are actually pretty interesting and have a dramatic impact on where vegetation is and just how we go about laying out a continent or region of one. If you'd like to subscribe to this free downloadable podcast, here's how to do it. For iPhone, iPad, and iPod listeners, grab your device and go to the iTunes Store. Then search for The Art of Worldbuilding. From there, download the free podcast app by Apple, and then subscribe to the show from within that app. For Android listeners, you can download the Stitcher Radio app, which is also free, and search for The Art of Worldbuilding. This only needs to be done once, because new episodes will become available in the app each time one is released, and you will never miss an episode. Let's talk about prevailing winds. What this means is that the winds are traveling a certain direction based on how far they are from the equator. In other words, how far from the equator those winds are. Fortunately, this is relatively simple. The winds that are closer to the equator in the tropics and subtropics are generally going west. By contrast, the easterly winds are the ones that are in the temperate zone. This is not to say that the winds are due east or due west, which means straight east or west. It means that they are westerly, for example. That means they're going mostly west, but they're kind of a little bit northwest. The reason we care about these winds is that, along with geography like mountains, this will determine where rain falls, and that in turn will determine where vegetation and lack of vegetation like a desert is. Since the rotation of the Earth is responsible for the direction of these winds, we need to be aware of which direction the Earth is spinning, which is counterclockwise, and which direction these winds tend to be in different latitudes, as I just mentioned. And the only reason we really need to care about this is that if we decide to change our invented planet so that it's rotating the other way, then all of these winds will also be the opposite direction. In other words, if the planet is rotating clockwise, then the easterly winds will be those near the equator and the westerly winds will be those in the temperate zones. I do have a figure number 17 on the website showing the prevailing winds that'll really help get this across. The biggest reason that we really care about these prevailing winds is that they are going to determine something known as a rain shadow. This is one of the big payoffs for listening to this particular episode of the podcast because this is really going to have an effect on your continent. What's going to happen is that there is moisture-carrying wind that is approaching a mountain range, and that mountain range will cause the atmosphere and the clouds to rise. And what's going to happen as a result of this is that a lot of that moisture is going to fall on that side of the mountains as rain. One result is going to be lush vegetation on one side of the mountain range. But as the moisture-carrying winds go over that range on the other side, there is now very little moisture in the atmosphere, and as a result, there's no rain to fall on the other side. So you're going to end up with a desert, and this is known as a rain shadow. A rain shadow can extend as much as 1,000 miles away from a mountain range. For example, in the United States, the mountains on the western coast cause a rain shadow, and this is partly responsible for the Great Plains that fill up the center of the United States. Why is that a plain instead of a forest? Well, because there isn't enough moisture to fall out of the sky to cause that kind of vegetation there. If you want to see this for yourself, you can go to Google Maps and zoom out on any continent or even the whole planet, and you can see where there is vegetation on one side of a mountain range and there is usually a barren area of land on the other side. This is definitely something you want to take advantage of when you are laying out your continents and deciding where a forest, mountain, and desert are. If you're enjoying the podcast, please rate and review the show at artofworldbuilding.com/review. Reviews really are critical to encouraging more people to listen to a show they haven't heard of before, and it can also help the show rank better, allowing more people to discover it. Again, that URL is artofworldbuilding.com/review. The last thing we're going to talk about are the climates themselves and where these are typically found. I'm going to keep this at a high level because it's kind of a lot of information to remember in a podcast episode for you. So you may already know some of what I'm about to say, but I just want to make sure we're all on the same page. Climate is a long-term weather pattern rather than the day-to-day changes. There are times in our modern world where someone is talking about climate change and someone points to the weather today to indicate that there is no climate change occurring, and this is a faulty argument. Such a person does not understand the difference between climate and weather. What is that difference? Well, weather changes from day to day. Climate is something that basically stays the same for a long time, but once it does start to change, that change is gradual and it moves in a certain direction and keeps moving in that direction, which is why we talk about global warming. If global warming will be followed by global cooling, that's not going to be for thousands of years. It's not going to be something that happens tomorrow. As far as climate goes, there are things that can affect that climate and change what we might expect given the latitude of the region we're talking about. For example, the terrain, the altitude, and nearby bodies of water and their current can all impact the climate in a region. The first kind of climate we want to talk about is tropical, which are those nearest the equator. There are several kinds of tropical climates, including tropical rainforest, tropical monsoon, and tropical wet-dry, which is also known as savanna. For most of us, all we're really going to care about is the tropical rainforest one, so that's what I'm going to discuss briefly here. This is usually found within 5 to 10 degrees of the equator, but can sometimes extend as far as 25 degrees away. The thing about this climate is that the seasons do not really happen here, as we were talking about earlier with anything this close to the equator. Most places are also wet all year round, and a rain shadow is not going to have as big of an effect here because there is just so much water. Let's move on to the dry climate. Naturally, such an area is known for how little rain it receives. What we really care about here is that there are 3 types of deserts: hot, cold, and mild. The hot deserts are sunny all year round, and one of the side effects of this is that they have extremely high temperatures during the day, but at night it also gets really cold. This is almost always found in tropical regions. We're not going to find such a desert in Canada, for example. By contrast, a cold desert is very hot during the summer, but the winter can be way far below freezing to the point of it being really dangerous. These are the ones that are usually found in the rain shadow of a mountain. They also occur at really high elevations. These are the ones often found in a temperate zone like in the United States. Finally, we get to the mild deserts, which are usually mild all year round, and are usually found on the western edge of a continent or at a high altitude. Earlier, we talked about how the western edge of a continent will have colder water, and that is partly responsible for these forming, so this type of desert is found on the western side of continents. That also means near the coast. What does all this mean for us? Well, we should have some idea what kind of desert forms where if we are intending to have our characters traveling through one of them, so that we can characterize it appropriately and distinguish one from another so that they're not all the same. Next, we get to the temperate climates, and once again there are a half dozen varieties of these that I'm not going to cover in detail. This is where most of the Earth's population lives, and that's partly because that's where most of the land is. These climates have all 4 seasons. I could go into detail about all of these, but I have a feeling they would put you to sleep. If you are really interested in this, I would suggest looking at the website, artofworldbuilding.com, and I do have a chart listing all of these out and making it relatively easy for you to understand them. It is figure 19, the climate chart. The next climate we should mention is humid continental, and what this really means these are the ones that are found in the interior of a continent away from the coast. Once again, there are a half dozen varieties of this. These are also found on the eastern side of continents because of the warm, humid air there. Forests grow really well in these climates, including evergreens and conifers. Rain tends to fall equally in all seasons. These differences and more are also summed up in the chart that I referenced earlier. The only climate left is the polar one, but you basically know what this one is. It's very cold. So to conclude our discussion about climate, I think the big takeaways for you are to just understand the equator's role and the ocean's role, and where there tends to be warmer and colder water, as far as which side of the continent, and then understanding the zones, the prevailing winds, and the rain shadows are the big one. As far as the specific climates, I would use that chart that I have on the website and go through that anytime you are getting ready to set a story in a given city, because you can decide what the weather is basically going to be like, from year to year, and whether it's going to be rainy or dry or really humid. And there are areas of different countries that are known for their weather. In the United States, the southeastern area is known for being really humid and hot. And by contrast, in the southwestern area, it's known for being really hot but dry. So this is the kind of difference that you might want to talk about when your characters are in a story, because otherwise you might just be tempted to make every place look like it's exactly the same. And we can create a better sense of realism by doing something with these climates. All of the show's music is actually courtesy of yours truly, as I'm also a musician. The theme song is the title track for my Some Things Are Better Left Unsaid album. But now we're closing out with another tune. This is A Sad Winter's Day from the Serenade of Strings album. You can hear more at randyellefson.com. Check out artofworldbuilding.com for free templates to help with your world building. And please rate and review the show in iTunes. Thanks for listening.